Welcome to Zero Knowledge, a podcast where we talk about the latest in zero-knowledge research and the decentralized web. The show is hosted by me, Anna.
And me, Frederick.
Hey, so before we start in, I want to speak to you briefly. So this is a bit unusual, but to be honest, we live in unusual times. So this show is released weekly, and we sometimes record some of our episodes in advance to have a small backlog of shows. We then air those over the following weeks. This, by the way, I'm just giving you a little bit of a look under the hood on how we do this over here. The thing is, with things changing as quickly as they are kind of on the world stage at the moment, our episodes that we're airing may not always reflect the latest goings on or maybe people's sentiments. And generally, this has been intentional. In a way, we've wanted these episodes to act as a resource and not necessarily be tied to any specific time. And so many of them are focused on a topic. The thing is, the past few weeks have been really wild. And so I just wanted to kind of check in with you and say hello. And thanks for continuing to listen. We plan on continuing to make these over the next few weeks, months, maybe years. But if it sounds like an episode is coming from a different era, like it's because we recorded them in advance when things were maybe a bit more normal. And hopefully they'll be normal again soon. Anyway, just a heads up, given the speed of change at the moment, I imagine there could be some twists in the coming months. For example, the ZK Summit, the event put on by this podcast, of which I've done 4, can no longer go on as planned for the 5th edition. So it was planned for March 31st, but like many events happening this month and next, and maybe after that, we weren't able to host it as planned. So the new plan is to host it online, which will be a bit of an experiment for us. And so we really need you to bear with us as we put it together. But this change could also mean a really neat opportunity for more of you to be able to participate. So I'll be sharing more about this over the next few days and weeks. If you already have a ticket, you can get refunded, as there will be a new cheaper ticket for the online version available. If you want to keep your existing ticket, that would actually help a lot in recouping some of the funds that we've lost on the in-person event. For this, I will definitely create some special bonus content, like thinking maybe we make an extra meetup or something like that. So yeah, just keep that in mind. If you have never heard of the ZK Summit and you're interested, well, please send in an application. I will share the link in the show notes. Once you've applied, I can then send you a link to the online version's ticket. I think it's going to be really interesting. I can't wait to see sort of the regulars who come to the summit every time. And I'm also excited to see if we can, have some new participants join us this time. Yeah, so I hope to see you there. Back to this episode. This week, we chat with Galen from the project Urbit. We recorded this a few weeks ago. It's a somewhat controversial project, as well as being a really interesting one. We spent most of this episode figuring out what Urbit is, and then at the end, we chat a little bit about what makes it a bit of a lightning rod. It's not necessarily a blockchain project, and it's not necessarily zero knowledge, but we were curious, and we hope you are too. Okay, so to wrap up my kind of unusual long monologue here, I hope you're feeling really safe and good wherever you are. I hope you continue to make time to stay curious about math, tech, and the humans that make up the decentralized/internet world. I think it helps to focus us to continue to think about a potential future that we want. And hey, if all else fails, just watch Star Trek. That's what I do when I'm feeling worried about the world. Anyway, thanks a lot. And now here's our interview with Galen from Urbit. So today we're sitting with Galen, who's the CEO of Tlon. Tlon is the company that works on the project Urbit. So welcome to the show.
Thanks for having me.
And we have Frederick over in Berlin.
Hello.
In this episode, we wanted to explore this project Urbit. And Urbit, as far as I understand, is not a blockchain project, but is very similar to a blockchain project or lives in the same world as a lot of the blockchain stuff that we've talked about. And I think both Frederick and I are really curious to find out a little bit more about what this project is, what it plans on being, and if there are connections to maybe some of the other topics that we've already covered on the show.
Yeah, so maybe to fill in how we overlap with the blockchain world first, and then we can get into like what Urbit is concretely and why it matters or why we think it matters. So in the simplest terms, Urbit is an identity system and an operating system, or what we call an operating system. It's really an overlay OS. So it's a piece of software that runs on any Unix machine with an internet connection. To log in or authenticate with that OS, which also runs its own network, you need an ID. That ID is registered through a series of, or like a suite of Ethereum contracts. Those are live and deployed. All of those IDs are ERC 721. So they're like non-fungible tokens that are, represent your identity and basically like hold a keychain that you use to authenticate yourself and like, as encryption authentication keys on the network for sending packets back and forth. There's kind of like a hierarchy of keys for how you secure that identity. We can get into what that is. So there's definitely overlap at the identity level. And then the operating system at the very lowest level is like a single function. And that function is deterministic. So your Urbit is like a pure function of its state, which of course is something that anyone who's familiar with blockchains is like, that looks like a little bit like a blockchain. Urbit doesn't do consensus. Like every node runs independently. But because they all share the same computing model, it's really easy to share programs, like send data back and forth, and you get all these kind of like higher order benefits, which are also a little bit like people are familiar with from these sort of more like global computers where they all share the same state. So Urbits don't share the same state. It'd be really easy to build a blockchain on top of Urbit. We often talk about it like, if you're gonna, today, in order for me to spend money or to interact with general purpose blockchains, I need a computer. And on that computer, I have a mnemonic, or in my head or whatever, I have a hardware wallet. So you need a key and you need a system to call out to a chain. Urbit's super compact, super simple. So we think of it like Urbit's a good complement to a blockchain. Like it's fast, it's super simple, easy to reason about its security. And so using it alongside a blockchain makes a lot of sense. So we've always kind of like coexisted with this world, but we're not directly in it.
So I think, the largest way that it's similar to the blockchain world, I think, is in the sort of vision statement, in what you're trying to achieve. You talk, like if you go to urbit.org, you talk about decentralized applications. You talk about a lot of the same goals, even like trying to remove the power from mega corporations and put it into the hands of the people. All blockchains talk about these same things. So like the goals are there, the vision is there, but decentralized app has to mean something else in your context, because blockchains talk about decentralized apps, or the pillars upon which you build decentralized apps are consensus and Byzantine fault tolerance. And those are not things that you have, as you just said. So how do you see decentralized apps differently from what a blockchain would see them as?
Yeah. So Urbit is very much aimed at personal computing in the most mundane of senses, like the sort of operating system side, right? Really like the two used together. So, one way to think about the OS is almost like, think of it like it's a meta protocol. It looks a little bit like a database, and inside that database, you can basically define something between like a stored procedure and a program that also makes it extremely easy to have that program share data across the network, compute with other nodes, and so on. So when it comes to things like chat, sharing documents, sharing links, sharing like other kinds of like type data, when I look at using basically sort of like a global blockchain-based computer for doing things like that, it's just technically really, really hard, right? Like you have to get that state to update among a whole bunch of nodes all at once. And all I want to do is like send a message to my friend. So Urbit sort of like takes just like another approach because our goal really is to like solve the like personal computing problem, like one Urbit node, one person. So this thing needs to store your data, do your computation. I think you can think about building an Urbit app on the OS side is kind of like you define a protocol and then build an interface for that protocol. It comes with a number of protocols kind of out of the box, and you could like build new interfaces for the existing ones. So it's a little bit different than, I think when I think of like really canonical, blockchain-based decentralized applications, ones that like really, really need a blockchain, something like Augur or Gnosis, things that require global consent. They need to be secured by global consent. It makes a lot of sense to use a blockchain. But when you're looking at something that needs to have really high throughput, needs to be fast, needs to be responsive, I mean, just from pure technical standpoint, I think like Urbit makes like a bunch of trade-offs such that you can, accomplish those things. And I think then it's also, the thinking is sort of like, well, if you needed to send money as a part of a message or, register a vote or whatever it might be, where you need trusted computing, like where you need a blockchain, then you should just call out to the chain, like have Urbit handle the, signing and sending of a transaction, if that makes sense.
The thing is, though, like Urbit as a project and the concepts around it, it started like kind of before Bitcoin, right? How old is the project?
So the project started as like a personal kind of like independent PhD in 2002 is the sort of reported number. Yeah. I think like I always like I'm like, no one really knows. You could think of it like Urbit walked out of the desert in 2013 and no one knew like where it come from. So yeah, Curtis worked on Urbit as independently for quite a long time. He built the kernel for the first mobile web browser, which I always think is kind of like important context. It's like someone who worked on basically getting a bunch of devices with under terrible latency conditions, right, to figure out how to compute together. And I think he looked at that problem initially and was like, this is a nightmare. This is really, really hard with the existing stack. I think I could rethink this, and then disappeared for 10 years to think about that problem. And so I found Urbit in 2013 once it was sort of like a basic prototype.
I see. So it's more like the origin story puts it starting a little bit before.
There. I mean, you have to think of, Bitcoin, there was already, eGold or whatever, right? There are like early digital cash projects have some of the cipher. It doesn't predate like the cypherpunks or anything crazy like that. But yeah, Urbit's, I think actually there's a blog post. I should know this, but the truth is I actually don't. Or I don't know the exact dates, but I'm pretty sure the blog post describing the PKI model. So we talk about Urbit address space as digital land because it's sort of like bundled into blocks of increasing size. There's no mining. You can think of it almost like it's pre-mined as sort of an existent distribution scheme we can talk about. That model, I'm pretty sure, was documented and published either, I think, before Bitcoin, the Bitcoin white paper. So I don't know. I always think of them as kind of like coming out of the same like primordial cypherpunk soup or something like that, but with just like slightly different goals.
Yeah. It's funny, like my first interaction with Urbit was probably 2014, 15, something like that. And it was like me and a friend.
This is probably at like Fugue or something.
Yeah, exactly. So it was me and a friend sort of found this project and we started digging and it was all this crazy shit, all these compilers and like odd languages and like lots of stuff to geek out on. And you download this thing and you run it and it's basically IRC, but you have some unique ID assigned to you. And it was like, okay, like I don't really understand what's going on with like behind it's IRC. That's cool. But it's like, I know there's a lot of shit here, but I don't exactly know what it is. But it was still a cool thing. And you sort of, but even then, like the vision was there to a lot, and like the website back then talked about sort of this OS and a global computer that replaces everything, and like everyone will just live in their Urbit and like you won't interact outside of it, and like I don't know, stuff like that. And then you went in and it's chat, and so it was a weird contrast, but it was still cool. Anyway, that was just a random story. My question kind of links into this.
It's actually like almost like an important. It's good context, I think, for people to know even like what the state of the project was at that point, because it's like the way that Urbit has evolved is important. But go for it.
Yeah. If you go to urbit.org today, there's this background image of video of an ocean. Is this a reference to people saying that Urbit is taking a boil the ocean approach?
That I should just say yes. The thinking, although I'm going to take the bait because I like what we have been thinking about in this regard. I think that Urbit evolved out of this basic intuition that like something else was possible, and like I think definitely Curtis and many of us really in the early days like not totally sure exactly what that looked like. But everyone who worked on Urbit came from like had a very technical or had a lot of experience with existing technology and a lot of like frustration with it. Basically, like it was like this just doesn't sort of match up with the values of kind of like basically like the early computing movement, right? Like computers were supposed to be these really wonderful tools, and why am I stuck talking to people on Facebook like that I can't really extend or change or do anything with? It just felt like extremely restrictive. And if you follow that rabbit hole all the way down without dragging everyone through that on this podcast, like I think that, you know, the sort of terminal thinking is like, okay, actually, this is a technical problem. Like, let's not get into what exactly you want the user experience to be like, but at the end of the day, like if someone is running the server for me, they're like deciding how I'm going to compute, like how I'm going to interact with people, how long my data is going to live, so on and so forth. And so that technical problem is a big problem. So you're basically thinking like, everything that we put on top of Unix to make the modern internet work is not going to work. Like we're going to basically throw that away and start over, which is a totally insane thing to say, but maybe also I would tend to think actually probably true. And there's a huge amount of technical work there. And you're like, all right, I got enough stuff to fix. You know, we'll figure out exactly what people do with this later. But we know that it has something to do with like, it's going to, you know, it's going to sort of absorb a lot of your daily computing sort of experience. So to draw it back to what you're noticing on the website, I think as we've gotten closer to being able to deliver something that people can use in a way that is richer than chat, although chat is definitely something people use Urbit for probably more than anything else, the thinking was sort of like what you really want is an extremely calm, straightforward, simple way to bring together a bunch of different modes of communicating and collaborating. So for you guys to get this podcast done, for us to get work done, for Parody to get work done, for anyone who uses the modern internet, I'm like switching between a bunch of different things. And there's something just like anxiety inducing about that experience. And what you want is for your computers to not get in your way. You want them to actually kind of be able to do the multitude of things that you need in order to collaborate with people. You want to talk to them. You want to share documents. You want to share links. You want to share all kinds of different types of content. You want to be able to edit them, and you want that to last forever. And you don't want to have to worry about anyone else, like any company, getting in your way. And so sort of the image of that, just purely from an aesthetics standpoint, was like, it should just be like you alone in the landscape. There's like, imagine the sort of like the modern world disappears, and you're left alone with kind of like an e-ink device that runs a computer that like will, you know, is meant to last 1,000 years kind of thing. So the thing we're trying to evoke there is this sort of like sense of calm and like kind of lack of dependency that I think the system is built to embody, like actually be. And yeah, no one would have, if you had in 2015, that was like definitely not clear to us. The funny thing about doing any project like this, right, is like there's all this stuff you just don't know yet. But you can't really fully concede that fact. You have to just be like, no, I think we know where we're going. And then eventually you refine and kind of adjust. But anyway, I don't know. Maybe that gives some background to the kind of look and feel.
I think there's an interesting thing in what you just said of owning your own data. An artifact of someone else owning our data is a proliferation of apps. And it is, to me, it is stress-inducing as well. Like, this guy over here wants his spreadsheets shown in some way. This guy over here wants it in a third app. This guy over here wants it in a fourth. So in the company, we end up using 5 different tools to do the same thing. But really, it's the same source data. You should just have 4 different ways of viewing it because the way of viewing it tailors to the person. But that's something that we haven't really started to address in any decentralized app space. Like people in the blockchain world and Ethereum world and otherwise, they talk about this as a potential, but they all still just go and build their dApp and have their UI on it and like don't really encourage or to some degree even enable other people to build their UIs on that thing. So it's interesting.
Like, I mean, in a way, the kind of great irony, or like just the funny thing about the way that we've gone about doing this project is that it is at once built on kind of like intuition about things that are fundamentally flawed in existing technology and a total focus on the user experience being kind of the only thing that matters. And so when you say like, yeah, in 2015 I used this thing, it's basically IRC. Like we, even still, like the most frustrating thing about Urbit is basically that, well, like we believe completely that the user experience is the thing that drives the adoption of new technology. It's the only thing that will validate our own contrarian approach to building technology, but it's not quite there yet. And so when I look at this landscape of, landscape basically people replicating, one of the, I think, real anti-patterns is like people replicating centralized services in a decentralized way. I mean, I support these efforts. Like, I think it's in spirit the right thing, but you're still, from a user experience standpoint, you're not delivering something that is good enough, basically, to attract, just in the most practical terms, like that you're not going to attract enough people to this thing because it's not exciting enough, it's not compelling enough, it's not new enough. Like that's just like the single hardest problem. Like if you can actually deliver a new experience of computing, then all of these kind of like protocol issues, these things will go away because people will actually want to use something that, you know, works in a particular way, delivers to them a new user experience. And yeah, I'm sort of stubbornly feel like the only thing that matters is unification. Like I just, if you add another app to my home screen, like you're not making my life better, basically. Like you need to remove, I want this stuff to go away. I want to actually get simpler. And if you can't make it simpler, then you haven't actually solved a problem necessarily.
And yet when it has been made simpler, for example, like Google kind of taking over a lot of the, you know, taking over the email, taking over the docs, taking over whatever else. Search was first, but taking over what they've taken over, we're still sort of assuming that company, I mean, we know that company is then going to own everything.
Right.
And I guess that's like, they're giving you the simplicity part. They're saying like, oh, well, you know, everyone will have an account. Everyone can log in. It's a little bit easier than like doing these other kind of apps where you'd have to share anything. And yet, they're not really going to offer you the chance to own it. It sounds like here the focus is really on the ownership.
I think it's like, we think of like the sort of guiding design principles are, you know, Urbit should be simple to use for an ordinary person and as to understand as a developer. It should be durable. It should last. It should outlive you. Like it should last forever, and it should be yours. It should belong to you in every way. Mm-hmm. So you want those things to work together. I mean, Facebook's always like a simple example, right? Because there are all these other social networks. Facebook won because like purely on interface, basically, right? It's like it was simpler, it was more straightforward, it was cleaner, and people.
I remember originally you thought it was private. It was introduced as private. You got to choose who saw what, whereas MySpace you didn't, and Friendster you didn't.
Yeah,
that was one of the biggest things that it offered, and I remember when it came out.
Yeah, it's funny. It was all kind of like about because it was. I feel like Facebook. Yeah,
it was private.
There's so many strange and interesting things about it, but it was also like you're this small community. It was all about this small community, which I like think about a lot. We think about a lot because that feels like the thing that has been somewhat erased from the internet. But I think that in the sort of Web 2.0 era, the big winners were ones that won on user experience, and we traded, you know, privacy and sort of durability or control for really good user experience, which I just am like, that's a totally sensible trade, actually, from a kind of economic standpoint. And I think that's kind of just that's the challenge to anyone who cares about ownership or decentralization. You have to like see it as a feature. You have to be able to deliver it as a feature, like as an end user. Someone has to be able to sense materially that is doing something for them. I think in the case of, and so when I look at like, certainly with Bitcoin, like Bitcoin does make, in very certain cases, it does make your life easier, right? Like it's delivering like a very straightforward feature of maybe remittance, or if for many people, obviously store of value. It's on those two verticals, it's like it wins unilaterally, and that's why it works. And it doesn't matter the interface in terms of like what do I use to log in or authenticate or whatever, it doesn't really matter. It's just like technically it wins. But I think outside of many of those things, or like outside of those things for Bitcoin, there might be a few for Ethereum. The effort has to be at like, at the kind of like at the level of an ordinary user. Like people have to start to think about it in that way. I think sort of like people in this space have to think about it that way. I think that's how we try and think about it in order to like just like be broadly successful. And I fully concede that we're not there yet, but I think that's like how we try and think about it. Getting closer, I think.
I want to start jumping into the tech and talking about what it actually is. But before then, I just wanted to throw another anecdote at you because I think it's also a potentially interesting conversation. I was at this WASM conference, and you make some references, again, in your website and your FAQ. FAQ is pretty comprehensive, by the way.
Thanks.
And you make some references to WASM as sort of a core sort of foundational technology. And there was this guy at this conference who said, laid out this vision of we're going to build everything on WASM. WASM is going to be like the foundational VM that every machine runs, and then we just build one unified OS on top of WASM, and then apps on top of that, and everything will be great. And I went, raised my hand and said, what you're describing sounds very much like Urbit. And his reply was, yeah, but I live in the real world.
Yeah.
And I imagine that when you started this and started building everything from scratch, you like what I'm picking out from what you're talking about, you did this because you live in the real world, or that's what you see, right? Where, no, the real world has a bunch of shit and we need to like start fresh. And this guy is like, no, I live in the real world because like WASM can interact with what exists and whatever. What's your thoughts on that?
Like we'll see. Basically, I think that's kind of a totally fair. I think it's worth maybe they come from different. The motivation is very different. I'm gonna like concede that my familiarity with WASM is probably not. Could be deeper. Maybe you can correct me potentially. But the primary motivating idea behind the Urbit VM knock is basically that you never, ever, 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 ever change it. Because you never change it, you can ship upgrades to the system over the network forever. So if I have an Urbit today, and actually, hopefully later this year, we're going to try to effectively guarantee this. And I put it in a drawer for 5 years, and I plug it in again. Like 5 years later, it'll just upgrade itself until it works again. And the reason that it's kind of the idea is to just be as dumb as possible, right? You're like, you want your VM to never change because then you can change everything else. And my understanding, x86 is not like this, which is why is a big part of why you end up with this complicated software stack on top of your hardware. And WASM, while it's a nice layer, it's still not simple enough to actually accomplish this ultimately user-facing goal, right?
Yeah. And I would say, while it's a goal for them to change less frequently, like they don't want to change much.
Yeah.
But it's still under control of W3C.
Yeah.
And there's still mega corporations basically in control of it. If they want something in it, it'll happen.
I think there's the culture of Urbit infrastructure development, and I think most of the work that we do is much more from the standpoint of like crafts people. Whereas I think that something like WASM to me is like this super professionalized world of software development. And I think that professionalized software development is kind of concedes that you're going to need this industrial scale armature of people and companies basically to maintain the world's software. And our approach is like, if you make it really, really simple, if you make it really, really well, then maybe you actually don't need that. And that's much more in the interest of the consumer, of people, because then they can actually potentially understand the tools that they use and improve them, which I would argue much better reflects the physical world that has far outlived any of our technical tools. And I think these are just totally different attitudes. And the thing that bothers me is ultimately that when you build a really complicated tool, it's like, who is going to maintain that thing? And if it means that, giant companies have to maintain it, I mean, it's not out of ill will that I don't want that. It's like, I just, how do I know how that's going to last, or what's going to happen to their, sort of profit motives? Like, where is this thing going to go? It's hard for me to reason about. So I think it's then reasonable to be skeptical of like how those things might evolve. And so, our attitude is like, no, make it as simple as possible, make it as understandable as possible for everyone who uses it. They're just totally different things. And we may be, maybe impossible, or we fully concede that we might be wrong about that, but seems like a good idea, basically. We'll see. Yeah.
So I think next up we wanted to move a little bit more into the technology of Urbit and what it's made of. I think in the introduction you did mention a few pieces. There's a clear focus on identity technologies. There's a focus on, you kind of called it an overlay OS. I when you said that, I actually made a little note. I wanted to dig into what you think of when you say that. And then there's a few other pieces that I think we should explore. But why don't we start there?
Sure, yeah. Why don't I just give kind of like an overview of what these pieces are technically, how they fit together, and try and just be as technically as specific as possible. So starting with the identity system, the identity system was actually originally a part of Urbit itself. Urbit was just this software package you installed on top of Unix. We found that in order for us to actually deploy this thing and let people own it, Urbit itself would have to be totally secure, which is a really tall order, given just the scale of what we were trying to accomplish. And this thing called Ethereum already existed, which would accomplish exactly what we needed to do. And by factoring out the identity system, we would end up with something that's totally general purpose and reusable. So an Urbit ID is basically just a number. Think of it as like any number between 0 and 4 billion. So what we want for an ordinary user is effectively to have like a username and password-like experience. You have this name that sounds like a name in a foreign language, like Ravmel Ropdile or Sorg Namtiv, or they're these strange synthetic names. They're pretty easy to remember. Each one of them is a number under the hood, right? We just take the number and turn it into something you can remember. The lower numbers issue the higher ones. So at the very top, there are 256 what we call galaxies. Galaxy each issues 256 stars. A star each issues 65,000 planets. Simpler to think of in base 2, so it's just 2 to the 8th, 2 to the 16th, 2 to the 32nd. There are also moons underneath planets. There are 2 to the 64th, which is a gigantic number, moons. You can think of it sort of like galaxies are kind of like the root DNS nodes. They're the core infrastructure of the network. They actually can vote to upgrade the rules of the identity system, like that's sort of built into the Ethereum contracts. Stars are kind of like your local ISP. They help do peer discovery. They probably provide services to individual planets, and then planets are for individuals, and moons are for their devices. So the way this distribution works is that effectively like a sponsor node sets the initial keys, and then you perform every subsequent key update. So that's how I can kind of like give you an ID. And then, of course, from then on, I can't take it back, right? If I'm a star and I give you a planet. You need a sponsor to be on the network. And we can talk about how the OS uses this scheme, but it could be used by anything.
By sponsor, you mean like an existing user needs to send you something? An
existing super node needs to just acknowledge that you are sponsored by it.
Okay.
The design of this system is motivated by two primary things. For any PKI or identity system to function in a decentralized way, you need some fundamental way of preventing Sybil attack, right? Preventing identities from being reused over and over, effectively to combat spam and abuse. So by making it finite, we say, well, they by default should have some value, and that value should be above what you would make spamming or abusing the network. And you also want the network to be somehow accountable. You want it to be like the foundation for reputation systems. It's not a reputation system on its own, but you want there to be some way of knowing when I meet a stranger on this network, like the default should be I should trust them at least a little bit, right? Versus like a random IP address. For anyone who's ever run like fail to ban or something like that, like a random IP address, you definitely do not trust, right? A random Urbit ID you should trust.
Why would you trust that though? Like, why couldn't it be a malicious ID?
Because hopefully it costs them $20, right?
Okay.
So a Gmail address, I think, costs, if you go, on the dark web, or I always hate when people say X is so vague. You go on Tor and find a marketplace. Sorry, I wish that's what journalists would say when they talk about the dark web. I'm like, it's well known what the dark web is. It sounds like something mysterious. Anyway, you go buy a bunch of email addresses. They cost you like, I don't know, 25 cents or something like that. There's a price. And so the idea being that if someone has a little bit of skin in the game, they don't want to abuse that address because then everyone would blacklist them. So I'm not saying that all of a sudden everyone on the network is friends, but they're probably not malicious is the thinking.
How do you keep that costs above the value made though? Because like that, I mean, that the problem with IPv4 and I assume the problem will be even bigger with IPv6 and Gmail addresses and everything is that it's too cheap, right? It is too cheap to get a Gmail address. And so I can buy one and spam the shit out of it and
then
I move on to the next one. So how do you ensure that the value of a planet actually stays at $20 or whatever it may be?
Yeah, we can't. The thinking is simply that you let the market do that, and you let the sort of scarcity tree sort of shape of the address space do that. And that you effectively put trust into all of the people who also run the network. So like the price of a planet right now is about $20. Why? I mean, there are plenty of planets, like, I'll give you a planet. But I think the reason it hovers around that is partially because everyone who's selling them, anyone who owns, really cares about the network itself. So they want to sort of protect it from, anyone buying en masse to try and abuse it, basically. Yeah. But ultimately, I think as Urbit grows, you're absolutely right that like it's not perfect. It makes trade-offs that I think are these trade-offs mostly in service of simplicity. Because I think if you think about trying to design, it's very difficult to design another mechanism. At least whenever I've reasoned about it.
I think the total addressable space should be this. Isn't it the same as IPv4?
Yeah, it is IPv4. Yeah.
Yeah. So. I mean, in theory, you should end up with a structure like IPv4, but I think the problem with IPv4 is we've come to the point where we just assume that identity is not tied to IP anymore.
Yeah.
And like an IP can be owned by me today and by some other random person that, has a contract with this ISP tomorrow. And so they'll be randomly sort of shuffled around. And therefore, we can't build a reputation system on it.
Yeah,
but if you have an identity that you explicitly from day one say there's going to be a reputation system around it, then it's also like a good reputation IP will cost way more than a bad reputation one.
Yeah. The way I often explain this is like you can think about Urbit as digital land, I think, right? It's this sort of vast territory that unlike land, which of course has natural resources, which make parts of it, more desirable than others, existing neighborhoods and so on. Urbit is more like this vast grid. And as it gets used, it sort of takes shape and neighborhoods develop. So certain stars may provide specific services in the way of like one of them runs a 0x relayer and one of them runs machine learning services and some are faster than others and so on. So definitely I think price differentiation, and actually you see some of this already, will be vast. Like there will be, a sort of unused, uninitialized piece of address space is totally different than one that has been operated that's effectively almost like a business. These are also likely infrastructure providers. So the idea is that you host an Urbit somewhere. So very likely, and we work on this a little bit, there's actually a separate company now, Urbit Live. There are 2 or 3 other ones kind of on getting started up, where the thinking is that they would provide hosting and do exactly this. So it's sort of like you go somewhere, you buy a name, you buy hosting, and you get kind of like the complete package from a provider who's also running infrastructure nodes. But anyway, now we're kind of out of the scope of what is Urbit ID technically. It's just this set of sort of special numbers that have a distribution pattern. At the beginning, one thing to mention, I think, is like at the beginning, all of this was effectively owned by Curtis, who wrote it. He sold half of it to the company for almost nothing when we started the company, or I was actually not quite there yet. And then the company and Curtis both gave almost half of their ownership to a future foundation, which is still sort of cared for by Tlon. And then since then, unfortunately you missed the boat on this, but in like 2014, 2015, you get a Galaxy just by like writing a little bit of code. And it was just easy to get large chunks of address space, lots of developers. Some of it was sold to investors. And then as Urbit has kind of gotten off the ground for the most part. Yeah, we sell address space to other people. Now it sort of trades on the open market, but it's all non-fungible. But anyway, it's sometimes people are always curious about the history of, how did this stuff end up in
which parts of what you just described are like Ethereum smart contracts or built out of Ethereum smart contracts? Because you started sort of with the Galaxy being everything.
Just down to planets. So we don't register moons on chain because there are just too many of them. So Galaxy stars, planets are all registered on chain. There's an interface for interacting with those contracts that we built and deployed. So if you buy one somewhere now, you can log in at bridge.urbit.org and like manage your identity. So, and then we give away these little cards that have a key on them. When you register this key, we'll derive keys for you using our key pattern, which is more username and password like, trying to kind of obscure the difficulty of BIP 39 or whatever. All that stuff is all done on Ethereum and doesn't depend on the OS at all.
Got it. So each one of the things is a unique NFT.
Yep. Yeah.
Okay.
They're all NFTs.
And they're connected to each other.
Yeah. They somewhat depend on each other. Like the sponsorship tree is registered on chain, basically. And then the Urbit OS listens to Ethereum and propagates key updates through Ethereum. There's kind of a key chain for each NFT. So I guess, to maybe dive slightly deeper into the technology, the idea is that each one has an ownership key, a spawn key, a transfer key, and what's called a management key. Ownership is obviously the thinking is put ownership in a safe, probably with transfer. Spawn you could keep on, in a locked drawer on your desk, and management is in an envelope on your desk. So management you use to boot a node. Spawn you use to spawn children or sponsor other nodes. And then ownership is the thing or transfer and ownership are effectively the same.
I'm just wondering because we actually did an episode a while ago on NFTs, or I think they were on ERC, the ERC process.
Yeah.
And we looked at ERC 721, and there were these, I don't know, actually, I haven't stayed up to date on this, but there was some new ERC proposals where you'd have if you had an NFT that was in a game and you wanted that game character to own a hat, you could actually use these. There was new ERCs around that.
Like protocols for how they would own one another.
Yeah, and I'm just wondering if you guys used that at all.
We may not even know about that.
Okay.
So maybe that's embarrassing. I'm not sure. I think we probably finished the contracts in early 2017 and spent almost the entire year auditing them because we wanted to be completely certain that they were secure. We deployed them very quietly in late 2017 and then announced them in early 2019.
Okay.
And late 2018. Sorry. That's right. It's we did that and then I think we kind of it works. The idea, obviously I was talking about before, is to not change it. So yeah, we don't think about, or we don't keep up to date, I feel really. But go ahead.
Well, I was just wondering, what happens if Ethereum changes?
Yeah, that's a good question. And it's one that we get a lot, especially from our community, many of whom are super skeptical of Ethereum. The thinking is basically that we have, this ownership registry that's pretty consistently updating, right, as ownership changes hands. And if there was anything that if Ethereum was going to go through a really crazy fork or who knows, any Ethereum actually is whatever being 51% attacked. The quorum of galaxies could basically just call a block number and just say, okay, look, at this number, we got to move. And so hang on to your keys. We're going somewhere else. Ideally, we would actually, what we'd like to see is that once there's, when we went on chain, there were about 5,000 owners total, maybe like somewhere between 3 and 5,000 stars, galaxies, planets. That's obviously like continued to, it's kind of like on a solid linear rise. It's a lot of people to coordinate. But the thinking being that once the Urbit OS nodes are more of them are online, still probably pretty good number of them online today, but once it felt like you could get consensus from inside Urbit itself, we just moved to Urbit itself. Yeah, we just have like the galaxies run their own consensus, and it'd be sort of totally self-run. Ethereum's great. We've always thought about it as like bootstrapping, and it could go on for a while. Ethereum works. Like we have no real like complaints about it. Developer experience is good, but yeah, there's like this sense where we're like, well, it's also kind of a liability. You just don't know what's going to happen there.
I mean, especially with the original philosophy of no dependencies and like actually, trying to build a sort of a new thing. But it also feels like it's an inevitability. Like it's not like, oh yeah, maybe it'll live on Ethereum forever. It feels like no. Once we can run consensus and whatever, have proof of stake or whatever within the Galaxy sets, within Urbit itself, then that's the obvious move, right? So
yeah, exactly. Yeah,
it's more of like when to get there rather than if.
I do think that it's really great that in the time frame that we've done it, we've been able to give people, like, moving to Ethereum has a great kind of decentralizing effect, because now that people actually hold their own keys and they can independently sell these things, move them around, start them. From a community standpoint, it's awesome. It's fantastic. Like, so I think it's definitely the right practical move. But then, yeah, there's this kind of, when we think about the super long term of Urbit, which we obviously do, or think of this as a super long term project, yeah, there's this kind of like, all right, there might also be some liabilities here that we like don't actually want. But we'll see. I think we just try and treat it as practically as possible.
Let's dive into the other side, which is Urbit OS and Knock, Hoon, all of these crazy fun things.
Yeah.
Something that you don't talk a lot about, though, and where I would want to start out, I like starting out here with most of these kinds of projects, is networking.
Yep.
How does networking work? What's the protocol? I assume you don't use libp2p.
Yeah. Yeah, we've thought about it actually, kind of, but we don't use libp2p. Well, libp2p should use our identity system, I think. The reason we don't use libp2p actually is because it's unauthenticated from an identity standpoint. Okay, let's get to networking. This is kind of at the top of the stack. So Urbit OS, you were asking earlier, why do we call this an overlay OS? And the thinking is sort of like, okay, you can get a Unix box with an internet connection anywhere in the world. There's probably one in your pocket, like Unix plus TCP/IP and UDP. It's like not going away. Everything on top of that, I don't know. So what we do is we basically build a formalized interface into Unix, which is using libuv, where we get file system events, network events, HTTP. So it's, file system, UDP, HTTP. There used to be TCP. We don't really use it anymore. And terminal events. And then we convert those into that event stream is what gets consumed by, at the very lowest level, our virtual machine. Anyway, Knock has pretty sure 13 opcodes. In any event, it fits on a t-shirt. It's extremely concise, just the spec. And it's, basically super, super compact, Turing-complete virtual machine. We, on top of that, have a programming language, our own language called Hoon. Hoon compiles itself to Knock, which is kind of cool. It's because we update it over the network, it has to be self-hosted from to technical standpoint, I always find this incredibly refreshing because if my stack trace like terminates inside of the language, I can actually just go read the compiler or go read the standard library, understand what's going on in the language. On top of the language, we have basically an event dispatch, which acts almost as like a kernel between a bunch of different kernel modules that provide a similar set of affordances to what you would think of from the web stack. So file system, network protocol, application sandbox, secret storage, and a build system. Also probably forgetting something there. Timers, few odds and ends utilities. From there, so that whole suite of things we call Arvo. So it's sort of like Arvo, Hoon, Nock is the sort of inside of Urbit stack. That whole thing clocks in at about 50,000 lines of code, which is super compact. I mean, I don't know, any technical person listening, that's like something that most of our infrastructure people like are comfortable traversing the entire operating system code base, which is really great, right? Like it's understandable.
This is 50,000 lines of Hoon, right?
Yes, yeah.
Which, to be fair, is like several hundreds of thousands of lines of even Haskell or something.
I wonder if it would be that bad, but yeah, it would be longer. It's important to note. So sorry, is like Hoon is purely functional, but it uses no reserved words. So it uses what we call runes, which are effectively the same as reserved words. They're just like the language operators. And so it looks really weird, and it's super compact at first. People who love people learn to love writing Hoon and do really, really like it. The original thinking was basically that, and this is true, although it makes for a really steep learning curve, is like when you look at Hoon, you don't really read the code so much as you just sort of see it, because you aren't doing this other operation of separating reserved words from like variable names. I mean, people are super critical of this, I think, for good reason. But one of the things I always find funny about it is that every time someone wants to criticize this, they act as if they're like the first person to discover that this is weird. We're like, yeah, it's weird. It's a very particular flavor.
But it's also not like completely unprecedented. There's APL. There's
K.
What's this? K exactly. The theory exists. I mean, there's other languages that do these kinds of things.
Yeah, it's not for everyone, but it's also way easier than it looks. We run a periodic sort of MOOC called Hoon School, which anyone can come and sign up for. And we find that for a new infrastructure hire, for a new person who's here, really working full-time learning Hoon, who's like an experienced programmer, a week, 2 weeks, it's not that hard. If the first day you're like, this is insane, what the hell? And then by day 3 or something, you're getting it figured out. For people who've never, we find actually for people who've never programmed before, sometimes it's even easier to teach them Hoon, because for people who have a lot of professional programming experience, you're kind of unlearning some stuff to learn Hoon. People are always like, well, why do we even have this language? Ultimately, it's because Hoon compiles to Nock. Like Hoon is basically like C to Nock as assembly language. It's a very thin wrapper over Nock. It kind of feels like Nock. You could write other languages, or you could like compile other languages to Nock. Potentially, we've done a little bit of research work in this area, but Hoon is not. We don't expect Hoon to be like the Python of Urbit or something like that. Like there will be other probably more expressive languages. Currently, actually, one way we think about this is sort of like Urbit should almost be like personal Firebase plus identity. So like Urbit should have much better HTTP APIs such that you communicate with Urbit primarily using just like JavaScript. It could be your Raspberry Pi that's a sensor that's just calling out to Urbit in an authenticated way. So Urbit has like defined protocols that then you don't have to learn. For most people, you don't learn Hoon. You just like push data into Urbit, pull data out of Urbit, and Urbit is kind of like this dumb event transceiver that just lives forever. Anyway, you want to talk about networking?
Yeah. So
there's a lot to it.
We've walked from like the thin OS shim getting some events through Nock, through Hoon, and now we're talking to other computers somehow.
Yes, yeah. So important, I guess you really made me realize one thing we forgot is we get events in, and of course we push effects out. So an event comes in, something happens, and then an effect comes back out. So in the case of networking, UDP packet comes in, that may trigger any number of things inside of the event dispatch sequence of the kernel, and then an effect comes back out. So how do we, I mean, to be honest, there's only so deeply that I can dive into the networking stack, but the basic idea is that because knock is deterministic and because we use sequence numbers, AIMS, which is what we call our networking protocol, it can provide exactly once messaging between Urbit OS nodes in a way where, from the standpoint of an application programmer, if I want to operate on remote data, I just act effectively like it's local data. And the networking protocol, sort of abstracts away any of what you would need to know about. You only think about messages, and at the application level, you only think about like OS level events, and it may be an event that is actually addressed to another node in the network. So the whole point of this identity system, right, is such that I can just say, "Hey, tell Sorg Namtive what's up," and the networking layer knows how to go and find that actually can use the ID hierarchy to go find the peer, then can figure out the underlying IP address and move that over to get that into effectively their OS at the OS level, and where the programmer doesn't ever have to really know anything about the networking stack.
Sounds a little bit like Erlang networking, where you have a process ID, and like the programmer doesn't necessarily need to care if that process ID is local or if it's a remote node.
Right.
That's
interesting.
Kind of resolves.
Actually, I'm not that familiar, but people keep telling me that we have a lot of overlap with Erlang.
So how does this differ then from libp2p? Like, how is and actually, I don't know if we've ever covered this, but how does libp2p send a message from one spot to another?
So, I mean, libp2p is like it's an agnostic networking protocol, and it's meant to be generic. So libp2p is really just a little snippet of header data that goes with like a connection handshake saying, I'm speaking libp2p with these protocols. What are you speaking? And they can agree on which sub-protocol they talk.
They do. libp2p does a lot of peer discovery, though, right? Like, isn't that a big part of it? You still need a hash and an address, but it'll find the other peer?
Not so. I mean, the thing with libp2p is one should really just think about it as this little header message of because that's then like both forwards and backwards compatible, but discovery is like a sub protocol of this. So you can go, I speak libp2p, here's a discovery request, and then if the other person speaks libp2p, they know how to interpret that.
Got it.
But so when I talk about networking, one of the things I'm always curious about is discovery. Like, how do you do discovery? Is it a Kademlia kind of thing, or have you found your own way?
Yeah, so we use the sponsorship tree. So like, if we're two planets and we want to talk, there's sort of two cases, right? We've never spoken, or we've never been connected, and maybe we've been connected but you're not responding. And in both cases, we effectively do the same thing. I ask my star, who asks their galaxy, who asks your galaxy, who asks your star. And we send, if we've never spoken before, we effectively send a first message through where you always are, you're like broadcasting to your parent, to your sponsor, just like, hey, here's my IP. We don't presently do anything to hide your IP, which is, I think, part of the thinking of like, Urbit is not a dark net. But actually, AIMS is transport agnostic and could be run over Tor. People have thought about working on that, which would change some of this. But in any event, just from a pure discovery standpoint, it goes up the hierarchy down to you, and then I attach to my message, here's my IP address, right? So my first message gets to you by going through our sponsors, and then you talk directly back to me, and we continue to talk until whatever. Maybe your Urbit's running on your phone, and you switch IPs, and then we go back through the hierarchy if the connection has been dropped. Pretty simple. It's similar to DNS, basically. And so you can see how maybe then the sponsor's quality of service matters. You want to be under a sponsor that's online and responsive and so on. But yeah, it's very simple. The DHT networking is cool, but hard. It seems hard from the perspective of Ames, right? It's like Ames is simple.
It's definitely harder. I mean, it sounds like like you said, with the service quality of Galaxies, it really, like, I keep having this in the back of my head that there should be a blockchain within Urbit that is a proof of stake chain, because then you can slash the Galaxies if they aren't online or aren't serving DNS requests correctly and all this stuff. Would be cool.
I agree. That's
so you already have all of the basics in place to do all of this.
No, this is like it's just never quite made it to the top of our priority stack. But like people have talked about this quite a lot. There's some tons of interesting, because you also kind of get stake in some ways for free, just given someone's ability to authenticate as a certain ID, right? So then their ability to run a chain is, or like, to participate in a chain in a particular way is really easy to reason about.
You already have Sybil resistances to some degree, although it kind of becomes problematic when that's alpha. Well, whatever. The other thing that I want to dig into and ask if, like, how you're doing it and what you plan on doing is with NOC, because you have this super minimal VM, 13 opcodes or whatever. They obviously need to be translated to x86 in some way. Yeah. Is that currently being interpreted? Is there a compiler? Yeah. How does that work? And
yes, there's interpreter.
What do you imagine how it will work in the future?
Well, one of our first batch of interns was completely, and this was in like 2014, was obsessed with the idea of building a NOC ASIC or even a NOC chip, which people still love to think about, and I would love to see happen, although hardware's scary, basically. I mean, it would be incredible, right, to have a machine that actually is like physically real or realized in that way. But anyway, for the time being, yes, NOC is interpreted in C. NOC has one very important opcode, which is basically the jet. And jetting basically says, hey, instead of running the computation in here, call a registered function. In the case of certainly crypto algorithms, right? Don't want to have to re-implement you just like, we like to wear our seatbelts. We use the existing implementations as much as possible. So in NOC, when you're going to run SHA-256 or whatever, that's running in a reference implementation. In C, that's not running in Hoon code.
I see. Sort of like host functions in WASM.
Yeah, exactly. Yeah, I think that is exactly right. And then there's also in simplicity has the same concept, which is similar. Just saying it makes a lot of, so it makes sense for crypto. It also makes sense for things like if you had a TensorFlow chip, right? You're like, definitely not going to run this machine learning algorithm. It would take the life of the universe. Please run it on this piece of metal. That is currently written in C. Yeah, I think I mentioned that. So we have an interpreter called Ver. It's written in C. It's pretty, it works reasonably well. We are sort of always want it to be faster and want it to be easier to reason about. It has its own memory model. It's pretty intense piece of C code. So we've been working on actually using Graal truffle, which is the sort of like the JIT, like Java JIT, to write a NOC interpreter. And so that's kind of like one leg of research work around here that seems pretty promising. So there may be a Java-based NOC interpreter reasonably soon, which also would be, from what we can tell, be significantly faster and would also let us do 64-bit. So Urbit is also limited to 32-bit at the moment, which is always driving us a little bit crazy. But of course, we would fix that.
It feels like if you can get to a stage where you're jitting, you're like that much closer to the machine level as well.
Yeah.
Another interesting intermediate between running an interpreter on a Unix machine and having an ASIC is having a unikernel that just runs the interpreter, right? And you're still just booting into an Urbit.
So we've done, we'd like to provide hosting ourselves, at the very least for our own Urbit nodes. So to make it really easy for someone to just go from an email link, right, to a running Urbit OS node. And so been working on, Kubernetes-based automation for this. And part of that, of course, is like packaging Urbit up such that, there's nothing else on there. You're not like, you don't have to like go run your VPS. You basically just say, spawn me an image that only runs Urbit. That far, we made it that far, which also, of course, splits out like persistence, right, in a Kubernetes-like way. I think the JIT project is definitely the like immediate future, though, just because I think it's like, for doing something as unusual as knock and trying to make it performant, that's just like the most. It seems like that's our best bet. But we're still, if like Chris Latner all of a sudden is like looking for a job, then happily talk to him. There's lots of fun, hard interpreter problems.
So you just mentioned before, real briefly, that you don't roll your own crypto. You tend to use like existing libraries. But I'm wondering are there any like, I don't know, like privacy technologies or systems, cryptographic things that you're exploring? Like what kind of cryptography exists throughout the system?
A lot, but it's mostly unremarkable.
I see.
So basically, like there's sort of like the standard suite of algorithms you would need to interact with a number of known blockchains, and for us to do networking.
Mentioning sending and signing transactions to these networks, does that mean you directly connect to those networks? Like, do you connect P2P to those networks, or do you send to like a local node that then forwards to the network?
Yeah, really good question. So for Ethereum, basically it's the latter. We've been working on sort of bolting on a Bitcoin SPV node to Urbit itself. So soon you'll be able to just like effectively set a flag or something. I'm not sure exactly how they set it up, but like, you can just say, please also build an SPV node on here, and then your Urbit can, talk directly to Bitcoin, which is cool. And I'd like to see that expand. It'd be nice to be able to do that with Ethereum also. The Bitcoin project, I'm pretty sure, actually has pretty much completed as in the last week or two. And I think there might even be someone was working on a Lightning node too, and there might even be like the option to do a full Bitcoin node at some point. This has been like one area of work. We have a lot of like sort of Urbit attracts Bitcoin maximalists, and I like Bitcoin. I mean, it makes sense to me. So we've been trying to sort of better support Bitcoin sort of natively within Urbit.
Cool.
That actually, like we did talk a little bit about your community. What is Tlon, and like how big is it? Like what is this thing that's building this larger project? And are there a ton of outside contributors? That's what it sounds like.
Yeah, it's pretty varied. So for a long time, Tlon was 5, 6, until basically like early 2018. We funded ourselves. So early on, Tlon was funded by Andreessen Founders Fund, Tim Draper, and some sort of old school Bitcoin people. And then we started to sustain ourselves by doing small address space sales, where we in 2016 and 2017 sold little batches of stars. And so the community, I think probably from that period, maybe 2014 to 2017, started to grow. Like we had increasing outside contribution and a small community of people that started to spring up. We started hosting meetups, which I feel like was like a good thing. So there's always been like monthly or bi-monthly things that we host at our office. And then, so in 2018, we sold a slightly larger chunk of the network privately. And we grew Tlon to about 23. And that's about the size that it is now. During that time, I think later in the year, another company got started called Urbit.live. It's totally separate. I mean, we know them, obviously, but they're more concerned with basically like onboarding and making sure that the experience of like buying an address, getting on the network is really good. And then only probably really just like over the course of 2018, 2019, like the community grew pretty significantly. I think like putting things on chain and just the overall, while Urbit is still slightly painful to use, like, you need to install this thing yourself. The user experience, I think, has gotten better to the point that people just hang out on Urbit, and there's sort of small communities that form on the network itself. So, we're kind of like the primary kernel developer, but we don't even hold, I think, sort of like the economic incentive has in fact acted as like a decentralizing force, basically, right? It's like other people are interested in participating in this thing, and so they've gotten involved either purely because they want to own a piece of it or because they want to build a company around it or whatever.
We already talked about Curtis as the guy who started this. He had a lot of the original vision of Nock and Hoon, and like a lot of this is coming from him, obviously. And it's sort of, whenever I talk to people about Urbit, he is one of the people, that starts getting talked about, both for good and bad. Like I have both sides where, a crazy dude who like invented a bunch of shit, and like it's cool to be able to do that. But then also like this whole political thing that I personally don't really know what it's about. But you mentioned it in your own FAQ as well. So I assume this is something that gets discussed a lot. Like he was a part of the company. There was a lot of controversy. He left the company. What does that all mean for both the project and for the company?
So I got involved in Urbit entirely because of the technology. Like, I mean, I was just sort of amazed that someone had gotten this thing to even work at all. And of course, later found out that, Curtis has a reputation as a writer and as like a sort of as a blogger and I guess a political thinker. But I always knew Curtis just as this like, I had like basically a personal, professional relationship working with this person. And I liked working with him. He's super, super polarizing for, I think, good reason. I was trying to put this in terms of kind of like the question I asked myself, because I think when people are skeptical of Curtis, I'm like, I was really skeptical of Curtis. Like, I completely understand why people would feel that way. The question for me was like, what is the goal? Like, is there anything in this system, technically in terms of its ambitions and so on? Like, let's assume he's Satoshi. Like what should we be suspicious about this thing? And I think, at this point, like, I'm the person with the most kind of like sway in terms of what we work on or whatever, it's like effectively kind of inherited leadership of the project. I took over as CEO of the company in 2015. I guess I've been in charge of this thing for some time. And I feel like I sort of like take complete and total responsibility for sort of like what the goals of Urbit are. And certainly like in terms of like, if I thought Curtis's political thinking actually had a huge impact on Urbit in a way that was suspicious or was not, in fact, in the interest of people using Urbit, then I probably like wouldn't be working on it. But it's Curtis was always like a huge PR liability. And in some ways, actually, like, Curtis was the person to start this project, but he was never the person to finish this project. And it was the nice thing has been seeing other people take ownership of it and take it on. People who don't like Curtis at all, get involved basically because they like believe in what Urbit has the potential to do. The practical thing worth mentioning, right, is in early 2019, Curtis left. He has no voting interest in the company, no voting interest in the network. But he does own some of the networks. So like he owns no galaxies, but does own some number of stars, which I like really should know. It's not it's nowhere near a impactful number in terms of control, especially because they're not galaxies. And that was his own choice. I think he understands his own position as like a super controversial person and was just like, you guys should take this and do what you can with it. I do think the right way to think about Curtis is this kind of like mad genius type, who then kind of just wanted to go and sort of disappear. Like the main thing that Curtis had was like the sort of hubris to even attempt this project, right? Like most people would just not work on something like this. Is so crazy. And so you need someone like that to get it off the ground. And that is definitely, it's like that's not what you need to actually make it work and make it make sense and make it understandable and function as a community and so on.
Interesting.
Yeah.
Urbit is much bigger than Curtis, and I think that's evidenced in the group of people who work on it, which is like widely varied. I think we also think about Urbit as sort of Urbit aspires to be neutral infrastructure. If there's any reason that is not true, or we are not able to achieve that goal, like we're also, I think, we welcome critique and criticism, and the sort of the culture of working on this thing is one that is spirited and open and straightforward. And so I think that's like the main I'm always like, okay, if you're worried about something, you should just come talk to us about it and get involved in some way, vet this thing. If there's something you think we missed, like, we want to talk about it. It's pretty much always been that way. But I think that it's sort of like, it's reasonable to be skeptical, and we too are skeptical, basically.
Cool. I think that's really helpful to help us understand how you think about it. And it's so funny because like that idea of the person starting the project may not be the person to lead it onwards. I feel like we maybe see replicas of that in some of the projects that we've encountered in the blockchain space as well.
I think that's the case for all startups. Like it is extremely, extremely rare that a founder should ever run a company forever.
Yeah.
Like at some point the founder should leave and just be the founder.
I mean, this
and,
is
like they can do something else in the company, but probably not lead it.
Yeah, definitely. Yeah. This also comes through in a lot of, I should think of some more specific examples. But the other thing that's funny about this is that there are many, like, Curtis was able to assert, to be able to produce a virtual machine, self-hosted language and operating environment that actually runs its own network pretty much as a solo project is insane. Like, it's totally nuts. It's amazing. And pretty much everything that, if you looked at Urbit between 2013 and 2016 even, that seemed technically weird or annoying about Urbit probably actually is weird and annoying and should be fixed. And so the thing that has almost the entire system at this point has been rewritten by the people who are here. And even now, I mean, we talk about changing and upgrading every single piece of this thing. Like, there are parts of it that need to be more intelligible. There are parts of it that are actually just completely wrong and should be fixed. Those for the most part, actually, there are less and less of those. But I think that's an important thing to understand about kind of like the role of this person is it's like he tapped into something I think a lot of people felt was important and needed to be done. But there was nothing about this beyond that. It's like it's owned by a bunch of other people. It's become a collective project.
So I want to say thank you so much for coming on the show.
Yeah, thanks so much for having me.
And helping us understand this mystery project that is Urbit.
Yeah, we're working on doing that. Hopefully that helps.
Thank you very much. And to our listeners, thanks for listening.
Thanks for listening.